now 2 minutes past 3. So let's start and let's give Rod enough time to share with us today. But before Rod starts his presentation, I just want to do my normal presentation about Cement and Concrete SA. And I trust you can all see my screen now. So with huge appreciation to our partner members, AfriSam, Lafarge, PPC, and Sapaku, our gold member, CRISO. We're very pleased to have 5 silver members, Jody Redimix, CoreStruck, the Quick Group, Seeker, and SNA. And then all our bronze members and their logos will appear on your screen, and more, and more, and yet more still. And I actually said at the bottom of that slide, will your logo be added next? If you're not a company member of Cement and Concrete SA, your logo unfortunately will not appear with our company members. But we're also very appreciative of all our individual members, and welcome to all of those who have joined us today. We've also got the emerging contractor members, 3 of them, our associate members, our academic members, and then last but not least, we're an international partner of the American Concrete Institute. I shared this with you when we last had a CONCRETEfix, but to remember that we've now been accredited as a voluntary association of EXA. That is our VA number. And remember, because of that, PR Engers and PR Techni-Eng members of Cement and Concrete SA can claim 1 CPD point for their membership and get a discount on their EXA fees. So a huge boon for our Cement and Concrete SA members who are also members of EXA. Then this is a very new addition to our portfolio. The members would have seen a member circulation about this. We've created a vacancy notice board on our website. This VNB was in reaction to all the phone calls that we received from people looking for suitably qualified cement and concrete staff, and from individuals looking for positions. Now, just to make it clear, we're not a recruiting agency. We will not enter into any correspondence with anybody, but this is a listing of available positions in our industry. And the way to make your position available is to get online, click on the link to add an available position. It will take you through the steps. Once Natasha has received your detail, it will be added onto our vacancy notice board. We trust that this will go a long way towards helping our industry and aiding both firms looking for staff and people looking for new jobs. Remember to read all about the membership benefits of Cement and Concrete SA on our website, or contact Natasha Pulse for more information. There's a wealth of information available on the website. We're also on Instagram and on LinkedIn. Please follow us, like, share the posts that you see there. And then just to alert yourself to the technical talk presented by the Western Cape branch tomorrow afternoon. It is a hybrid event, so you still have time. If you can't make it to Cape Town, or if you're not in the Western Cape area, go to the link and register to follow this talk online. It's on LC2 in concrete. It promises to be a very interesting talk by Professor Karen Scrivener from Switzerland. And then the big event that's happening on the 29th and 30th of August, CONCRETEFiX. It's the first national conference on concrete roads and allied structures. It is a free webinar over 2 days. You will find detail on the Cement and Concrete website. That's where you can register. There is also a sponsorship opportunity where all the proceeds will be donated to Gift of the Givers. So please make sure to check this one out on the website. To date, we've got just about 500 people who've registered to attend these 2 days. It's free of charge, and it promises to be huge and very interesting. I know on a concrete roads perspective in particular, that Brian has organized a number of speakers, a number of international speakers. So it's really going to give us the latest of technologies. Publications for sale. I won't go into too much detail. You're all aware that Cement and Concrete SA have got a number of publications for sale. Our quarterly magazine, Concrete Beton, it's a digital magazine. The September issue will be available within, well, less than a month's time. And then remember, professional education to accelerate your career in concrete technology. Contact the School of Concrete Technology to discuss that. Their education program is available on the website. And without further ado, that's it about Cement and Concrete SA. I'm going to stop sharing now. And then I'm actually going to get Rod Rankin's presentation up for us. Let me do that, Rod. There you go. And Rod is now going to take over from me, and he's going to be presenting to us. Rod, over to you.
Thank you, Andy. I'll just move the computer over here slightly. Thank you, everybody. It's great to be here. First question, as always, can you see and can you hear? Can somebody just give us some feedback if you can hear me and see the presentation?
Yes, we can.
Yes, yes.
Right. Okay, let's go to the first slide. So there's just an overview of what I would like to speak to you about today. I'll show you the physical mechanism which causes surface delamination. And I want to spend most of the time talking about aggravating factors, those things that can increase the risks of surface delamination. And then I'll consider some other things like dry shake hardeners, and I'll try to give you some practical guidelines in terms of how to mitigate risks for yourselves as contractors. I think there's a few flooring contractors here today. There's also some concrete suppliers and probably some consulting people as well, and some specialist floor contractors. We'll talk about planning a pour and how we can try and nip some of those potential problems in the bud. But what I'm not going to speak about very much is how to repair delaminations, because that's another subject on its own. But if you've got some questions, we can address that later in the Q&A. These are just some pictures that I thought would be useful so that you can see the sort of problem that we're talking about. There's just a few on different sites, different investigations that I've done. Notice on the left-hand side of the image here, the circular scratch marks. Those are quite indicative of troweling that's done too late, and also the voids here, which are not filled up with paste. I'm not going to speak too much about too late troweling. It's usually a timing issue, but too late is fatal. And then these are the tools that I use to detect delamination. So on the right-hand side, you can see, and these are tools that I make myself. It's a chain pram. So I've got some polyurethane suitcase wheels which run very quietly across the surface of the floor. And there's some light chain. This is links that are about 6 millimeter in diameter. The diameter is not critical, but as you run it over the floor, you hear a different sound. And on the left, what I call a cat of nine tails, which you can use to fine tune where the perimeter of delamination begins and ends. So it's very simple technology, but you need a sensitive auditory device capable of detecting small changes in amplitude and small changes in frequency. That's called a human ear. Nothing more complicated than that. And the whole problem related to delamination stems from the fact that concrete bleeds. Concrete bleeds because of all the ingredients that we put into concrete, water is the least dense. So the solid particles of cement, sand, and stone, think of a handful of cement and a handful of sand and a handful of stone thrown into a bucket of water, those are more dense than the water. So they're going to settle, and the water is going to rise to the surface to make space for those solid particles to settle. And as it does so, as it migrates up, it encounters solid surfaces like this particle of stone, and it gets trapped beneath these horizontal surfaces. There's another horizontal surface, and it forms what's called a bleed water lens or a bleed water discontinuity. And the paste beneath the stone surface here, and it could be a rebar surface as well, can't bond onto that undersurface because there's a physical discontinuity. There's a physical interruption, a lens of water, which stops it bonding. And the way that we deal with that in concrete is we revibrate concrete, or we shake it to release that water and to help the stone settle. The bigger stones tend to settle more quickly than the smaller stones because they have a smaller surface area to volume ratio, and that's called Stokes' law. This is a schematic, a cross-sectional elevation through a concrete floor. This concrete floor is cast between two walls, and to make it interesting, I've put some damp-proof coarse plastic on one side of it only, but that terminates over here approximately, and this side has no damp-proof membrane. And so what happens when you fill this up with concrete and you compact it? Eventually the concrete will go off, and the first place that the concrete goes off is around the perimeter over here, and on the right-hand side over there, the concrete will stiffen and stop bleeding there first. And then it will stiffen fastest where the concrete section is thinnest. But over this deep section here, it will continue to bleed for longer, and it will remain plastic for longer. Because there's more volume here, the bleed volume is proportional to the volume of concrete. And where there's more depth, there's more volume, but the surface area remains the same. So it's going to bleed more, and it's going to bleed longer. It also bleeds longer because water from the bottom here has got further to migrate upwards. And it migrates through capillaries. So you get lots of little capillaries starting at the bottom. And these capillaries join together. They coalesce with other capillaries and then coalesce again. And the bleed water eventually finds its way to the surface. Now, the big reason for delamination is that when we power trowel concrete, or when we hand float concrete with the steel trowel, we seal the surface. When you trowel concrete, either by hand or with a power float, what you're doing is you are squeezing together the particles of cement, and there may be some particles of fine sand in there as well, and you're squeezing out the water. The water comes to the surface and then it evaporates. And what you effectively make is an impermeable layer, a layer that's impermeable to moisture and air bubbles. So when this bleed water hits this dense layer that you've power floated, it just accumulates underneath the crust that's power floated. And the trouble is most flooring contractors, most laborers who operate the power float don't realize that this is happening just beneath the surface. And just like the paste below can't stick to a particle of stone in the picture that I showed you previously, the presence of this bleed water lens here prevents the paste underneath from attaching to the surface. So what you've got is this crust that's unsupported, and this layer is a millimeter or less thick normally. When you put traffic on that, it disintegrates. The other thing that this diagram shows is that where there's plastic, there's no absorption of moisture from below. But where there's no plastic, if you place concrete onto soil, which is compacted and not saturated, the soil provides a very useful function of absorbing some of the excess bleed water, which shortens the route and reduces the total volume of bleed water that has to rise to the surface. And so it makes the contractor's job easier. It enables the contractor to get onto the floor to commence finishing activities sooner. And of course, you're also going to lose bleed water by evaporation, hence these arrows at the top show evaporative losses of bleed water. And this is a thin section. What's it? Actually a thick section. It's a concrete section. It's a core that was about 25 millimeters in diameter that we've cut a longitudinal section through recently. And prior to me drilling this core out of the concrete, I impregnated the bleed water lens with some petrographic epoxy resin so that I would exactly preserve the dimensions and the shape and everything of this lens. So that black line there represents epoxy. And prior to it having been epoxied, it was just a void. And above here, what you can see is a dry shake hardener. You can see that this void more or less is at the interface between the dry shake hardener and the concrete underneath, which had a dolomitic aggregate for sand and stone. And then it was polished. So you get an idea of what it looks like there. Not often that you see a picture like that. And then this is what's called a thin section, albeit this is a very thick, thin section, because what I wanted to show very clearly was the discontinuity, the bleed water which has become trapped. And what you can see here, because this is a photomicrograph under polarized transmitted light, you can see the different color in the aggregates. This is quartzitic aggregates, it's quartz, and it has all these rainbow colors when you look through with transmitted polarized light, whereas the dolomitic just comes up as dull gray. And what I want you to notice here is the width of the discontinuity. It varies a little bit. And the fact that it varies a little bit tells you that this was formed during construction when the concrete was still plastic. If this was a crack which had happened afterwards, then it would either be perfectly parallel and of a consistent thickness, or it would be tapered. Think of cracking any solid object. Two halves are mirror images of each other. They're perfect mirror images of each other. And the only way you could get a taper would be if you lifted the one broken half slightly more than the other broken half. But the fact that there's some variation in the thickness of this discontinuity is evidence that it happened when the concrete was still plastic. It happened on the day it was made. So it's not really a latent defect. It happened on the day that it was made. It's more a patent defect. And there's another image. And what this image shows you is some of the quartz grains have become unstuck. And they now serve to prop up the surface. When you drill for oil nowadays with fracking, one of the things they put down with that fracking cocktail is a whole lot of sand granules. And the purpose of the sand granules is to act as what's called a propant. They call it a propant to jack the crack apart and allow gases to flow through. And so the same thing happens here. These become dislodged during construction or shortly afterwards, and they actually form pillars of support. So they make the very fragile crust here even more vulnerable. Obviously, that's the surface of the floor. And then this is a couple of millimeters beneath the surface of the floor. And if you drop something on it, it'll crack. You can also see, you can just see some hairline cracks in this crust of dry shake hardener that's been applied to the surface. Those can be from plastic shrinkage, drying shrinkage, and also just impact fracture. And this gives you an idea of the scale. That scale bar is 2 millimeters wide. There's another image showing a propant particle. So how do we prevent this problem? So the very first bit of advice I would always give you is, as far as possible, only do power floated or delayed trial concrete surfaces in an enclosed environment, in a building where the envelope is sealed against the elements. You must have roof sheets on the roof. You must have sidewall cladding on the side walls. And if there's doors and windows, you need to try and seal those as well. What you want to try to create is a microclimate, a microcosm, where you're not going to be interrupted by drying winds and disrupted by a thunderstorm or something like that. If you can control the environment, you've got a very good chance of overcoming the problem of delamination. And the golden rule number one with floors, is uniformity. And if you read Brian Perry's book, Concrete Industrial Floors on the Ground, which he wrote as a co-author with Louis Marais, he does allude to uniformity, but he actually needs a whole page devoted to that. One chapter, one page, and just emphasize these things because it's very overlooked, very poorly understood. Everything about the base and the compaction of the base and the composition of the base must be as uniform as possible. The thickness of the concrete slab must be uniform. The concrete that you purchase must be uniform in composition and slump and everything. There mustn't be excessive delays waiting for deliveries. You also don't want many trucks in a queue waiting to offload. You want everything to progress smoothly, in sequence, and uniformly. And even the sequence of placing and compacting and leveling and finishing must be in the same order. You do it sequentially. What you place first, you compact first. You level first, you finish first, in that order. And your exposure conditions must be uniform as much as possible. And your timing of your curing and your duration of your curing must be uniform. If you get that right, you've got a better chance. But there are some conditions that are very risky, especially if you're working outdoors. And on a high felt, between August, this time of the year, and the end of October, it's very dodgy, because this is the time of the year when the temperature starts to increase. It's the windy time of the year. October is the windiest month. And it's also very, very dry. The relative humidity in Johannesburg at the moment can start at 50% in the morning, 60% in the morning. And by midday or 2 o'clock in the afternoon, it can be less than 10%. That's quite typical. And if you have a look at a psychometric chart, like this chart on the right, also from Brian's book, you'll see the effect of wind. Wind is particularly bad, and that's why I say do your power floating indoors. Don't power float externally, because that's just asking for trouble. But be very careful of conditions where the concrete looks like this. So this was a very workable concrete mix that was delivered near Vereeniging a few years ago. And within 5 minutes in the wheelbarrow, it formed a crust. And if you tried to turn it over, these crust particles would form. And if you ever have that, my advice is don't firstly cast concrete slabs. That's quite important, and especially if you're going to power float them. And if you have to, then what you must do is put a sheet of plastic over the surface and let the bleed water come through, sweat through to the surface, and rehydrate that crust. It's not really set, it's just stiffening prematurely due to loss of water from the surface only. And here's a test that you can do. If you stand on the concrete, if it's formed a crust, you very often see cracks adjacent to your footprint, like these cracks here. Whereas if you stand on concrete which hasn't crusted, which is ready for troweling, it'll leave a shoe print more like that. And if you put both feet on the concrete and you rock your body slightly from left foot to right foot, you transfer load from your left foot to your right foot, you very often find that the surface appears to go soft It initially feels hard and crusty, but as you rock and you get more of these cracks forming around your foot, you start to sink in. That's a very good indication that it's not yet ready for finishing. If you finish at this stage, there's a very, very good risk, very high risk that you're going to encounter delamination later on. And if you use a wood float and you're floating it and you lift the float and the surface is all stuck to the float, that's another indication of crusting. So this is my remedy for crusting. This was a slab we cast in Botswana under about 35-degree heat. And just putting a sheet of plastic over the top helps to rehydrate that crust. But I wouldn't recommend normally casting at 35 degrees in Botswana. There's a very simple test that you can do, a very effective test to determine the time at which bleeding has ceased under these conditions. You take a plastic bucket, preferably with a lip seal lid, and you get a hypodermic syringe, and you make a mark on the inside of the bucket corresponding to the thickness of the concrete that you want to cast. And you fill this bucket with concrete up to that level, and you compact it, and you level it as you would your floor. And you go and put it in the same environment as your floor. So if your floor is indoors, don't leave the bucket outdoors in the sun. Put it indoors in the shade. And then every half hour, come back to this bucket, tilt the bucket over very gently so you don't jolt it, and draw out any bleed water from the surface using the hypodermic syringe. You can make a graph showing the time and the amount of bleed water collected. And you'll see that it will start off bleeding at quite a high rate, and then it quickly tapers off asymptotically. And what you don't want to do is start your floating activities and your troweling activities before this concrete has stopped bleeding. And even after it's stopped bleeding, you've still got time. It's not panic stations. It takes quite a bit of time normally before the concrete goes off. Now, something else that you've got to be very careful of is using a concrete with a high extender content. And the worst culprit is fly ash. The best concrete to make a floor with is concrete with no extender whatsoever. But you can sometimes, if you know what you're doing, go up to about 15% extender for fly ash, and sometimes people go a bit higher for slag. But ideally, you want a concrete that sets as quickly as possible and finishes bleeding as quickly as possible, because you've got a team that needs to get on with their floating. You don't want them standing around all day, and you don't want them tempted to start floating too early. The problem with fly ash, these are particles of fly ash under a microscope, an electron microscope. And what you notice is they're spherical, they're glassy, and some of the bigger ones here that have broken are hollow. There's no chemical reaction that's going to take place. Nothing significant is going to take place while the concrete's plastic. These particles are smaller than cement, so they tend to provide more surface area, which uses more water. It holds more water, and the water is adsorbed onto the surface of the fly ash particle. It's not absorbed. And you place this concrete containing fly ash, and then the fly ash relinquishes water in the form of bleed very slowly over a much longer time than it would if you just used ordinary Portland cement, just cement, which is pure clinker. And so you really don't want a highly extended cement. The two most predominant motivating reasons for people to put extenders into concrete is A, for economy. If you live in somewhere like Johannesburg, which is quite close to sources of fly ash, the coal burning power stations, it can give you greater economy. And the other reason is people are trying to make their concrete greener, which is commendable. That's a very good thing to do normally. to make the footprint of the building as low as possible, but only if it doesn't compromise the durability and the performance of the concrete. And in that respect, I would recommend you don't put any fly ash in the concrete if you've got a choice. Just remember that the greenest way is not to build the floor at all. If you're building a floor in a warehouse or a factory, much better not to build a warehouse or the factory in the first place. That's the greenest option. Repurpose an existing warehouse. But if you're determined you have to build a new one, for heaven's sake, build it so that the floor lasts at least 100 years. We have to start building durable structures that last. We have to build quality. We can no longer afford to build stuff that has to be broken up and replaced after a short duration. The other thing that I would recommend is that you never ever power trowel concrete or trowel concrete which has got an air entraining agent, because this is almost guaranteed to cause delamination. There's lots and lots of literature about this, but we don't make a lot of floors with air entraining agent in. And sometimes people are tempted to put an air entraining agent in a freezer room floor. And it's normally not necessary. If the freezer room remains frozen and doesn't defrost too often, you're not going to get freeze-thaw damage due to lots of cycles of freezing and thawing. It's better not to put it in. If you're determined that you have to put it in, then I would strongly recommend you tell your client that you're not going to power trowel it. And if he forces your hand, you write him a note and say, we're doing it, but understand that we take no responsibility if it delaminates. But preferably don't even do it, because your reputation is going to go with it. The problem with air entraining agents is firstly that the little bubbles tend to block the capillaries which allow bleed water to come to the surface. So it reduces the rate of bleeding, it delays bleeding, and when bleeding eventually does happen, it goes unnoticed and you've already troweled it hard. And the other problem with the air bubbles is that the bubbles themselves get lodged underneath the crust. And when you power float, the trowel elongates these bubbles. The trowel will also spread the water laterally. It forms a wave, but it forms elongated air bubbles instead of round circular air bubbles. And when that happens, it further creates a discontinuity. And then if you can avoid putting plastic underneath the floor, please avoid putting plastic underneath the floor. There's sometimes when you have to do it. If you're building one of these large jointless floors, it's often required to reduce friction between the base and the underside of the concrete so that the concrete's free to contract, to shrink without cracking. But if you're building a conventional floor and you don't need plastic, don't put plastic down. The plastic aggravates the problem of delamination, as I explained earlier, by preventing any absorption of moisture by the soil. So it also causes other problems with curling. It exacerbates the problem of curl, and it exacerbates the problem of some joints opening but other joints not opening. So you get, wherever you get an induced crack on a saw cut joint, that joint tends to open very wide where the next 3 or 4 or 5 joints don't open at all. And you get problems with load transfer and disgruntled clients and rocking slabs. And then if you can avoid pumping the concrete, avoid pumping the concrete. It's usually not necessary to pump an industrial floor because you can just discharge straight from the ready-mix truck. Problems come when people put things like reinforcing in and you can't drive a ready-mix truck over it, or there's insufficient headroom like you've got here for a ready-mix truck, or you're working in a refrigerated environment, you're building a freezer room floor and you've got polystyrene insulation and heating coils under the floor. Then people might need to pump. But mostly I think of pumping and the requirements for a pumped concrete mix and the requirements for a good industrial floor as being mutually exclusive. In order to make the concrete pumpable, you've got to add a whole lot less stone. You've got to take about 150 kilograms of stone out of the mix, and you've got to substitute that stone with more water, more cement, and more sand. And those are the problematic ingredients for a floor and for delamination. The more stone you can have in the mix, the more volumetrically stable that is, and the less cement paste you have in the mix, the less chance you have of making a crust that traps water. And then be very aware of power floating outdoors. There's a good British Concrete Society book called Exterior Concrete Paving, and they make a very good case for not power floating ever outdoors. You want a textured surface so that people don't slip or vehicles don't skid when it's wet. And you just expose yourself to so much more risk if you power float like this guy. One of the problems when you're outdoors is that there's bound to be shadows. So some of the concrete will be in shade, some of the concrete will be in sun. The concrete exposed to the sun is going to be ready for power floating before the concrete in the shade. That's going to cause timing issues. So here's a very good example. When do you put the power float on? It's a conundrum. If he puts it on when it's ready here because it's been baking in the sun, it's not going to be ready where it was in the shade. And how does the operator know? This shadow is moving all the time. It just complicates life and increases your risk of failure. And then also be very careful where you've got differences in thickness. I remember I showed you in that first slide, where the concrete's thin, it'll go off and be ready for finishing sooner than when it's thick. So here we've got a waffle coffer type suspended slab with very heavy reinforcement. This is in a motor car factory in Silverton. And the problem is that if we put concrete here, the concrete over the deep sections is not going to be ready for troweling when the concrete over the thin section is ready for troweling. And that second picture of delamination that I showed you came from this job. Wherever there was a deep section, there was delamination. And wherever it was thin, it was successful. And how does the poor operator time his troweling efforts? He can't put the power float down where it's deep only and then come back later and do everywhere where it's shallow. He has to do it all at once. And so he's going to be forced to make a compromise of either he's probably going to trowel some parts way too early and other parts way too late, and it's going to be a disaster. So just don't do that. And similarly, where you have a waffle raft foundation, don't be tempted to power float it. It's often done. The specification from the architect says power floated waffle raft. And then the owner comes crying because he gets delamination. And typically the delamination is these bits here, which are deep. Unless they power floated like one of the other pictures that I showed you the next morning when the concrete had all set. And then you get those circular scratch marks. And if you have a thickening for a machine base, in this case it was vehicle hoists in a motor car workshop, do not be tempted to cast the whole floor at once, because this concrete, where it's thicker, is going to be bleeding for much longer and is not going to be ready for finishing when this thinner portion is ready. Rather cast this as a separate entity altogether first with plate dowels, so that you can cast the other thinner bits afterwards. And yeah, you would use the traditional long strip casting method to do that. And then, for heaven's sake, also, please don't put microfibers in your concrete. Microfibers are often recommended by salesmen for use in slabs to combat the problems of plastic cracking. If you half competent as a flooring contractor, you know that you don't need to do anything about plastic cracking. You can eliminate the plastic cracks as they occur. You will do anyway if you build a floor properly. And this schematic just shows you the difference. So here's a slump of a mix without fibers of 160. Take that same concrete and put it back in the mixer with microfibers, and the slump comes out to 50. So you've lost more than 2/3 of your slump. And what the salesman will always show you is a picture of concrete with plastic cracks in it without microfibers, and another picture of the same concrete with no plastic cracks in it, which had microfibers added. What they will never tell you is that to do that test, they didn't add extra water. But we all know in the real world, if the contractor wants a slump of 160, but he only gets 50 because of the microfibers, he's going to add extra water. And adding extra water just perpetuates this problem of bleeding. You don't want the extra water. So don't use microfibers, and they don't make the concrete any stronger either. Microfibers have an elastic modulus about 4 times less, at best, than the elastic modulus of the concrete. And if the elastic modulus of the fibers is less than that of the concrete, it cannot reinforce the concrete. It can only perhaps hold the broken bits together. So don't use microfibers. And where people have used them, here's a picture. They didn't even mix in properly. The biggest problem with these microfibers in any concrete is getting them to disperse. And very often they form balls, and you'll see it as a crater in your concrete. And if you dig into that crater, out pop the fibers. They're serving absolutely no purpose whatsoever. Unnecessary, leave them out. And then the other thing I want to just talk about briefly is these laser screeds. Laser screeds they've become very popular in the last 2 decades. But all they really do for us is make it possible to mass produce enormous areas of floor. Flooring specialists like them because they boost their turnover. They don't need as much labor. And unfortunately, you never get anything for nothing. The trade-off comes with quality. The problem with these machines is that they can only go over the concrete once. They're not very good at revibrating concrete. And when you use them, you get this huge wet edge that you've got to maintain all around where it works in a big semicircle. And very difficult for the trades that come after to finish the floor, because it's difficult to know which was the youngest concrete. You want to do your finishing activities on a FIFO basis, first in, first finished. And you're more likely to get problems with delamination. The other problem is if you've got a floor that needs a dry shake hardener because there's steel fibers in the surface, the dry shake hardener has to be put on too soon. It's got to be put on where the dry shake spreader can reach if you're applying it with a spreader. And so you put it on much sooner than you would otherwise want to put it on. And that extra cement in the dry shake tends to promote crusting sooner and obfuscate those critical telltale signs that tell the operatives that the floor is ready for casting. If you want to build a quality floor that's flat, the best way is to use the long strip method. It's labor intensive. We live in a country where we've got 50% or more unemployment. What we should be doing is employing people, employing laborers and upskilling them, teaching them to build good floors, not investing in laser screeds. And unfortunately, a lot of companies in this country see a laser screed as an asset, but they see human beings as a liability, as a cost. And they don't invest in human beings like they invest in machines. Try investing in human beings. Treat them well, and you can get very good results. So the other thing is, don't be tempted to just add extra cement. A lot of people think that adding extra cement is a panacea to all sorts of problems. It can actually make the problem worse because it makes the concrete crust quicker, and it accelerates curing. It accelerates set in especially hot, dry, and windy weather. It makes it less permeable. The other problem that you sometimes get with too much extender is dusting surfaces. If you take a wire brush and you rub it on a surface which is properly, densely power troweled, or even hand troweled, what happens is you don't get the concrete dusting, but you get a black mark. It's called a burnishing mark. And that's because little particles of iron come off the bristles of the wire brush and are deposited in the pores of the concrete. But if you've got a weak, friable dusting surface and you brush it with a wire brush, you'll get a pile of dust. So one of the things that specifiers should specify for a floor that needs abrasion resistance is some sort of an abrasion test. Even if you use this wire brush test, this very simple subjective test. Here's an interesting case history. This was a freezer floor that was built, I don't know, about 10 years ago. Huge floor, about 40,000 square meters. And the consultant who designed the concrete mix for the floor was based in the Netherlands. And instead of just taking one of our best ready-mix suppliers' standard floor mix and applying it to this floor, he reinvented the wheel. He designed a mix which had about 66% extender. And they had huge problems with dusting and premature surface abrasion. And we drilled some cores out of this floor and we subjected them to the old PCI wire brush abrasion test, where you've got that circular wire brush and it goes clockwise and anti-clockwise a given number of cycles. And this was the result. You could see how different parts of this floor responded to the wire brush. So this was obviously the worst and this was the best. And then we cut 10 millimeters off and we applied the wire brush a bit below the surface, 10 millimeters below the surface, and that's the result that we got. I built a floor for myself about 11 years ago, and I used a stock standard mix. I just said I don't want any extender in it. And I bought the concrete from Meteor for the garage below my new office at my home. It was a standard 30 MPa mix. And we used a hardener. We used David Sampson's MBFT dry shake floor hardener. And after a few years, it was probably 5 years later, no, 3 years later or 4 years later, I drilled a core out of it and I tested it. So this is my floor with the same wire brush test as these, just a standard mix with a floor hardener. And what we found was quite interesting. The average strength of this concrete was 53 MPa. The average strength of my 30 MPa concrete was 53 MPa. All that I did differently was that I took a standard 30 MPa concrete mix and I just managed the bleed water. And by getting the bleed water out, I got the strength up. And by having the right type of concrete surface and troweling at the right time, I got a very good result without even trying too hard. So if you do have delamination, one of the remedies that's often used is grinding. And this is a floor before grinding and after grinding. You can see one of the problems with grinding a floor with steel fibers in it is that you expose the steel fibers. That's what it looks like. It will change the aesthetics of the floor, but it often removes the very weakest, most dusty layer, which was high in water content. And the other remedy is to patch it with a proprietary type of self-leveling compound. And neither is ideal. So the old adage of an ounce of prevention is better than a pound of cure is very true for floors. Rather, take the time to make sure that you don't get delamination in the first place. Just follow these basic rules that I've given you. And one of the best ways to learn, and the two people that have taught me the most about floors are probably Brian Perry and Dave Sampson. This was the first floor that I built. This is hand troweled without a dry shake finish, so you can do it. A good way to learn is to build a floor yourself as an amateur like myself. And then this is the floor that I built with the hardener below my new office. And that's the result. And in the first case, this floor that I just showed you, we got slight delamination in one place, just here, the size of my hand, but nothing else. This one we got none. And the other thing you can do, I'm always casting panels of concrete for my residents association and myself. I made a whole lot of these pump chambers at my house, and I make them in temporary molds out of offcuts of chipboard. I just seal the chipboard with silicone and packaging tape, and then I try to float the top as well as I can. So it's a great way to learn. You try to make it that both sides look as though they were cast against a shutter, and you use the basic tools: wood float, plastic float, and a steel trowel, and you can learn such a lot just by making something small like this. So we talk the next slide. I'll just talk about a wood float, a plastic float, and a steel trowel. You can use a wood float or a plastic float as much as you want before the crust forms, and you won't seal the surface so that you get delamination. But the moment you put a steel trowel on, if there's delamination, or if there's bleeding and you've troweled it prematurely, you're going to probably get delamination, because this trowel compresses, it compacts the concrete, it squeezes out water from the surface, and it makes a very, very dense impermeable crust, because the paste doesn't stick to the underside of the trowel. If you suspect for some reason that you've started sealing the surface prematurely, you've started troweling prematurely, don't worry. Take your wood float or your plastic float and rub the surface with that, and you'll break that seal. Water will be able to come to the surface again. And when you trowel, you actually want to do so only when all bleed water's gone and the surface feels quite firm. And then when you commence troweling, you put that trowel flat. You don't incline it at an angle. You need to put like a third to half of your body weight on that trowel. And as you do so and you move it laterally, it feels like there's a film of oil being exuded out of the concrete onto the base of that trowel. That's the right time to start troweling. But most people start prematurely. And if you're going to use a dry shake, you wait until it looks counterintuitively too dry, until it looks like there's not going to be enough moisture in that concrete to hydrate the dry shake. But you'll see that the moisture will come through. It will be drawn through because the dry shake is hygroscopic. And it'll form a very nice paste. And that little bit of drying, if you deplete the surface of moisture, that's great. There's plenty of water underneath that can come and moisten it again. Remember, you only need about 4.5 liters of water to hydrate, to chemically hydrate a 50 kilogram packet of Portland cement. That's at the stoichiometrically optimum ratio. And just practice. The more you practice, the more of a feel you get. Unfortunately, this is not something you can learn in a textbook. You've got to actually get your hands dirty and build a floor. And for those of you who haven't done it, I would encourage you to practice on something small. Make something small and practice. And to give you an idea, the last 2 floors I built were in 2012 underneath my new office. We built one in June of 2012 and the other one in October. In both cases, the concrete arrived at 8 o'clock in the morning, dispatched from Pomona, came right across town, a distance of about 60 kilometers. We placed the concrete immediately. And in June, we only started putting the dry shake on at about 5 o'clock in the afternoon. We packed up and went home 10, 11 o'clock that night. In October, we put the dry shake on at about 3 o'clock in the afternoon or 4 o'clock, and we packed up at 8 o'clock at night. So if you're not waiting that amount of time, you're probably doing it too quickly. And my mix had no extender in it. If there's fly ash or slag in it, you're going to have to wait even longer. I just want to end up by talking about our behavior, the way we conduct ourselves in this industry. I would appeal to you to conduct yourself more like a specialist professional surgeon when he speaks to his patient. He says to the patient, if he's a good surgeon, he says, let me talk to you about the risks associated with the operation we're doing. These are the things that could go wrong. These are the things I'm going to try and do to help it go right. You have a role to play too as the patient. You need to prepare yourself for the operation. You need to fast before the operation, etc. And when he does that, it places the patient in a frame of mind where he's more likely to accept something that goes wrong. Okay, he knows there's a risk, and he knows that it's potentially not all the surgeon's fault. There's certain things that can go wrong, regardless of how well that surgeon conducts himself in the operating room. Similarly, there are certain things that are going to go wrong when you build concrete floors. It's an incredibly risky business. I feel for people who build concrete floors. I have the highest respect for them. I would never want to do it for a living. Believe me that they earn every cent of their salary. They work long hours under difficult conditions. Their floors usually one of the last things on the contract, and they're expected to pick up the slack when everything else is behind time, and the contractor has and the client has an inflexible deadline. And even if that flooring contractor does everything right, things can still go wrong, and you can still get delamination. That's something that you need to speak to the client about. And as far as he's concerned, the best outcome is the client shrugs his shoulders and says, oh, the floor's okay, it's acceptable. If anything else happens, he's in for the high jump. And you need to also think about, explaining who's responsible for what and what defects can be repaired and what defects can't be repaired. And that sort of thing should probably also be written into the specification. And if the client's determined that he's not prepared to accept defects, he must also be made to understand that if he insists on panels being broken out and recast, that floor is going to cost him a lot more, because the contractor's got to build that risk into his price. And usually when a client sees that, he quickly accepts some risk very willingly. So other important measures is a very good idea to have a pre-tender meeting of stakeholders, and you include the concrete supplier and the specialist flooring contractor. And you emphasize the importance of uniformity in everything you do. You emphasize that you cannot accept out-of-tolerance slumps, because those are going to cause timing problems. And you're not going to accept doctored concrete. If some concrete comes with zero slump, you're not going to put rescue admixture into that concrete, because that's going to cause a problem with timing. That particular load of concrete is going to go off at a different time. And you're not going to accept redirected loads. So if your ready-mix supplier gets a rejected load of 45 MPa self-compacting concrete, you don't want that dumped on your floor where you've ordered 30 MPa at 75 or 100 slump. You want to agree the procedure. You want to agree how rapidly the trucks come, and you want some facility to slow them down or speed them up. And you've got to agree contingencies for interruptions and load shedding and equipment breakdowns. And lastly, I would highly recommend a trial mock-up. If there's a part of a factory floor which is a small room for recharging batteries or forklifts or something, I recommend that you cast that floor first as a trial, and that you iron out your problems. Use that for troubleshooting and fine-tuning, and iron out all your problems on that, and then use that. If it's acceptable to the client, you use that as a benchmark of acceptable quality. It is a good way to prevent future arguments. That's the end. I don't know if there's any questions.
Well, Rod is available for questions. I found that talk very interesting. And Rod, I want to thank you for your your calm, practical way of alerting us to everything that can go wrong. Any questions for Rod? Rod, it seems like you're off the hook. I don't see any raised hands. I don't hear any questions forthcoming.
It wasn't controversial enough.
And Rod, Teresa from NPC says, thank you, excellent case studies, much appreciate your talk. And I think that is most probably what comes out of this, that you really gave us lots of food for thought, lots of practical examples on what to do and what not to do. But ladies and gentlemen, in my excitement to introduce Rod to you, I didn't even give you his CV. I think most of you have had experience with Rod in the past. He's done a couple of other concrete fixes for us, but believe me, he is very suitably qualified to talk to us on this subject. He's got an ACT diploma, he's got BSc, MSc, and PhD from WITS. And apart from all the work that he does in the concrete technology field, he's also he's developed a plate dowel system and installation machine for retrofitting the edges of industrial floor slabs for load transfer, and that's called the retro dowel system, which is actually trademarked. So believe me, Rod is really well qualified to talk to us on this subject. I see that we've got another comment, a very interesting content, that's from Richard Hugh, which all concrete contractors must be aware of. So I think that concludes today's CONCRETEfix. Thank you everybody for coming online, for joining us in this meeting. Hope you found it informative. If you do, please let us know. Give feedback to Natasha, give feedback to us. And if there's any other topics that you want to be addressed, please let us know so we can get the appropriate speakers. I remember Rod mentioning in the beginning that the repairs for delamination does not form part of this talk. If that is something that he can talk to us about in future, maybe that's a follow-up discussion. But thank you, everybody. Go well. Keep your eyes open for all the notices and for future events. Thank you so much. Goodbye.